So right now I am going to start vector. Let's start. Uh, in physical quantity, there are two types of physical quantity. One is scalar and other one is vector. Now scalar are those physical quantity which has only magnitude. What do you mean by that? For an example, mass. For mass, if I go to buy some rice, I will say give me 5 kg of rice. Here this 5 is the magnitude and kg is the unit. But when I am talking about something like force, if I say I am applying 3 Newton of force, now 3 Newton of force in which direction? If I am applying 3 Newton of force in this direction or this direction, it meaning changes. So those quantity, to identify those quantity we need magnitude as well as direction. Those quantities are called vector. Let me go to definition of vector. Now as it is written here, definition of vector is it should have magnitude, it should have direction, and it should obey triangle law of vector addition. Now you understand what is magnitude and what is direction, but triangle law of vector addition you will understand just after some time. I will discuss about it. Okay, how to represent vector graphically? Graphically we represent vector with an arrow. How to represent vector algebraically? Algebraically we represent vector with an alphabet and arrow on the head, as you can see. How to represent vector magnitude? Now magnitude of a vector represented by length of the arrow. Let's say I have a vector of 2 Newton, then I will draw like this. Let's say this is 2 centimeter of length. I have another vector having same direction but 4 Newton, then I will draw an arrow of length 4 centimeter. Let's say I have another vector of 3 Newton force, then and it is upward in direction, then I will take a length of 3 centimeter and direction is upward, and this is 3 Newton. Okay. Now this is what relation of between length of the magnitude of the vector and length of the arrow. Now how to represent magnitude of a vector? If A is a vector, then its magnitude is represented by this kind of sign, A mod, or simply A. For an example, there is a force and its magnitude is 4 Newton, then I will write F and its magnitude is 4 Newton. Am I clear? Good. Types of vector. There are different types of vector. Excuse me. First is parallel vector. Now parallel vectors are those vectors where these two vectors are parallel. Let's say this is A vector and this is B vector. These two are parallel. That means angle between them is 0 degree. Great. Antiparallel vector. Antiparallel vector are those vectors where angle between them is 180 degree. That means they are antiparallel. Orthogonal vector. Orthogonal vectors are those vectors where angle between them is 90 degree. Great. Null vector. Null vector are those vectors where the magnitude is 0. It represented by, algebraically it represented like this, 0 and an arrow sign, and graphically it is represented by a point. What about its direction? A null vector has all possible direction. In some book it is written it has no direction, but that is wrong. A null vector has all possible direction and its magnitude is 0. Before going to unit vector, I will discuss two more vector, equal vector. Let's say A is a vector and B is a vector. If these two are equal vector, then first of all it has to be parallel. That means angle between them is 0 degree. And second, magnitude of A must be equal to magnitude of B. Then I can call A and B are equal vector, and I can write A vector is equal to B vector. Negative vector. In negative vector, magnitude of A and B has to be equal and angle between them is 180 degree. That means they are antiparallel and magnitude of A is equal to magnitude of B. So I can write A is equal to minus B. A is negative vector of B or B is negative vector of A, whatever. So if this is A vector, then negative vector of A is minus A. I hope till now it's clear. Next is unit vector. Students, unit vector is very important. Let us understand. Now unit vector is represented like this, E cap or any alphabet into E cap. E is an alphabet. From the name only it's clear that its magnitude has to be 1. Any unit vector magnitude has to be 1, or a vector having unit magnitude is called an unit vector. Now the important thing is any vector A can be represented by its magnitude multiplied by its unit vector. So here the A cap is, magnitude of A cap is 1. So for vector A, simple A is the magnitude and A cap is the unit vector. It represents the direction of A. It will be more clear when I go to triangle's law and then resolution of vector, it will be more clear. For now, you take it as it is. Okay, so now we will go to addition of vectors. Okay, how to add scalar? If I will take 5 kg plus 3 kg and I will ask what is the answer, you will say, sir, 8 kg. Yeah, you are correct. That's how we add scalar. But how to add vector? If I have a vector A and vector B, then what is the resultant? How to add a vector? For an example, I have a force of, let's say, 5 Newton and 3 Newton. What is the resultant? Is it 8? In this case, yes, it is correct. The resultant is 8. But in this case, 5 and 3 are acting in opposite direction. Is it 8? No, you are correct. That's 2. So here it is 5 minus 3, 2. What if I am adding 5 and 3 in this direction? Now you don't know. So we will now calculate how to add two vector. Now the problem is vector are not only magnitude, it has direction. So we cannot add vector like we add the scalar. So we will now learn how to add two vector using triangle law of vector addition. Let's go into triangle law of vector addition. In this video, I will complete triangle law of vector addition. Next video, I will go to resolution. Let's proceed. Now, let us consider two vectors. As you can see, A and B. This is A vector and this is B vector, making some angle theta. Guys, I am providing you notes also, so you can write it down, or after the class I will try to give you the PDF. Otherwise, you please write it down, pause the video and write the notes. So, A and B vector making an angle theta. How to add these two vectors A and B? So, connect tail of B with head of A. So, let me do that. Let me connect tail of B with head of A. So, as you can see here, I have connected tail of B with head of A. Okay? Okay. Now the resultant is from tail of A to head of B. Now the resultant is from tail of A to head of B. Let us see in details. Now let us do some maths. So I have two vectors A and B, as I have shown you, A and B, making some angle theta. I connected tail of B with head of A, and resultant is from tail of A to head of B. Angle between A vector and B vector is theta. Let me name some point. This is point O, this is point A, this is point B. Great. Now let me draw a perpendicular from point B to the OA line. So this point is now C. This point is now C. Great. Now let me use some trigonometry, that is, one second, that is in the triangle ABC. Look at here, in the triangle ABC, in this triangle, let me use sine theta, that is equal to BC by AB. But you know AB is simply B, that implies that BC is equal to B sine theta. Similarly, cos theta is equal to AC by AB. As you know, AB is equal to B, that implies that AC is equal to B cos theta. So here AC is B cos theta and BC is B sin theta. Now look at the triangle again, where AC is B cos theta and BC is B sin theta. Now I want to use Pythagoras theorem on the bigger triangle OBC. So when I use Pythagoras theorem on the bigger triangle OBC, I will write OB square is equal to OC square plus BC square. Now OC is OA plus AC. OC is OA plus AC, and OB is the resultant. This OB is the resultant R. So in place of OB, I substitute R, and OC is OA plus AC. Let's proceed. But OA is A and AC is B cos theta. So I substitute that OA is A, AC is B cos theta, and BC is B sin theta, and there is a square, so B square sin square theta. Now a plus b whole square formula I have written here. I am using that. So a square plus b square cos square theta plus 2ab cos theta plus b square sin square theta. Now I will take b square common and this cos square theta plus sin square theta in the bracket and 2ab cos theta. But you know, in school you have studied that sin square theta plus cos square theta is equal to 1. So here I substitute 1. So a square plus b square plus 2ab cos theta. That means resultant is root over of a square plus b square plus 2ab cos theta. Great. Now you got magnitude of the resultant in the form of a, b and theta. But is it all? See, vector has magnitude as well as direction. Now we find magnitude r. What about direction of the resultant? Let me say resultant is making an angle epsilon with a vector. Then on this triangle tan epsilon is equal to BC by OC. But BC is B sin theta and OC is OA, that is A, plus AC is B cos theta. So A plus B cos theta. So epsilon can be written as tan inverse of B sin theta plus A plus B cos theta. Don't worry about tan inverse. Just if tan theta is x, then I can write theta is tan inverse x. Later in mathematics, you will study about inverse trigonometry. For physics, it is not required. Just I wrote in that form because in most of the book they wrote in this form. Great. So finally, we got if A and B are two vectors acting at an angle, making an angle theta, then the magnitude of resultant is root over of a square plus b square plus 2ab cos theta, and let's say it is making an angle epsilon with a vector, then epsilon is tan inverse of v sin theta divided by a plus b cos theta. Now let me give you the definition of triangle's law. Triangle law of vector addition states that when two vectors are represented as two sides of the triangle with the order of magnitude and direction, then the third side represents the magnitude and direction of the resultant vector. What does it mean? This is a triangle, or let me do another triangle. This is a triangle, and two sides of the triangle represented by two vectors in one order, then third side of the triangle is the resultant. Resultant is a plus b in opposite order. Let me draw one more triangle. If this is a triangle, if this is a vector, if this is b vector, in one sense, then resultant r is a plus b is third side of the triangle in opposite sense. That's what triangle law is saying. I hope it is clear. Otherwise, pause it, go back and go through it again. This is a YouTube video, so I don't want to repeat anything. If you want repetition, go back again, go through the video. Okay. There are some special cases like when theta is 0 degree, A and B are two vectors parallel to each other. In this case, cos 0 degree is 1. So using the formula, your formula is R is root over of A square plus B square plus 2ab cos theta. If I substitute cos theta as 1, then I will get a square plus b square plus 2ab cos theta is 1. But this formula is a plus b whole square. So magnitude of the resultant is simply a plus b. And in this case resultant has a maximum value, that is a plus b. Case 2, when angle between A and B are 180 degree, that means they are anti-parallel. In this case cos 180 degree is minus 1. So again in the formula I will substitute cos theta as minus 1. So a square plus b square minus 2ab. This is formula for a minus b whole square root over, that means r is equal to magnitude of a minus b. In this case the resultant will give you minimum value. Now case 3, when angle between two vector is 90 degree, you know cos 90 degree is 0, so you will get r is equal to root over of simply a square plus b square. Okay, very good. This is all theory for triangle's law of vector addition. Now we will solve some example and question. First one, I have two vector, one having 4 Newton magnitude, other one is also having 4 Newton magnitude. Angle between them is 60 degree. We have to find magnitude and direction of the resultant vector. So let's do it. I have two vector. One is having magnitude 4, so let me take a vector has magnitude 4. B vector is also magnitude 4. Angle between them 60 degree. Let me substitute in the formula. So r is equal to a square plus b square plus 2ab cos theta. A is 4, b is 4, 2ab 4 cos 60. Cos 60 degree is 1 by 2. So I'll use this. Cos 60 degree 1 by 2, 2 cancel. 4 square plus 4 square plus 4 square is 3 times 4 square. This is root 3 into 4 is the answer for magnitude of the resultant. But we also have to find direction. For direction, I'll use tan epsilon, this formula. Tan epsilon is equal to b sin theta by a plus b cos theta. B is 4, theta is 60 degree. A is also 4, b is 4, theta is 60 degree. Sin 60 is root 3 by 2. Let me use it. Here 4 I will take common. So 4 and this cos 60 degree is 1 by 2. 1 plus 1 by 2 I have solved here. It is 3 by 2. So 4 cancel. Root 3 by 2, 3 by 2. 2 cancel. Root 3 by 3 is 1 by root 3. 2 cancel. Root 3 by 3 is 1 by root 3. You know from school that tan 30 degree is 1 by root 3. Here tan epsilon is 1 by root 3. So it's clear that epsilon is 30 degree. We got the magnitude of resultant is 4 root 3, epsilon 30 degree. Let us see in the diagram. So this is the resultant. Its magnitude is 4 root 3. Angle it is making is 30 degree. Now let me give you a question for you. Pause the video and solve it. This is the question. Find the magnitude and direction of the resultant vector. You have two vectors, one has magnitude 3, another has magnitude 4. Answer I am giving you, I am not solving it. The magnitude of the resultant is 5 and epsilon is 53 degree. To solve this, I am giving you a hint. Tan 53 degrees 4 by 3. I am not solving it. This is very easy. You can solve it. I have confidence on you. Definitely you can solve it. So I will discuss few more questions for better understanding, as the video is focused not only for board or IIT, all the entrance, IIT, Neet or any other entrance, whatever you are focusing, for all these things this video is focused. So I will solve few more questions. So this is the question. This is previous year entrance question actually. For the resultant of two vectors to be maximum, what must be the angle between them? Pause the video, answer it. Tick, tick, tick. Let me do it. So for the resultant of two vectors to be maximum. So already I discussed in special case 1, that resultant is maximum when angle between them is 0 degree. So here the answer is option A, 0 degree. I know many of you have solved it. Congratulations. Next question. Forces F1 and F2 act on a point mass in two mutually perpendicular directions. The resultant force on the point mass will be. So solve it, pause the video, solve it. Tick, tick, tick. Let's do it. So you have two forces F1 and F2 acting on a point mass in two mutually perpendicular directions. So this is F1 and this is F2. Again already discussed in special case 3 that in this case, when angle between them is 90 degree, resultant R is equal to root over of A square plus B square. So here answer is root over of F1 square plus F2 square is your answer. Next question. The magnitude of vector A, B and C are respectively 12, 5 and 13 units. A plus B is equal to C. Then the angle between A and B. Let me tell you, 0 means 0 degree, pi means 180 degree, pi by 2 means 90 degree, pi by 4 means 45 degree. You may not know the radian, that I will discuss later after vector. So right now use this. So this is also previous year entrance question. So pause the video, do it, tick, tick, tick. Let me solve it. So the magnitude of A is 12, B is 5 and C is 13. So I will write C is the resultant, that is equal to A square plus B square plus 2AB cos theta. Now C is 13, A is 12, B is 5 plus 2AB, 13 into 5 cos theta. So let me write root over, let me take it and write 13 square, 12 square is 144, 5 square is 25, 2 into 13 into 5 cos theta. 13 square is 169, 144 plus 25, 169 plus 2 into 13 into 5 cos theta. Now 169 cancel. That implies that 2 into 13 into 5 is equal to cos theta. That implies that cos theta is equal to, oh sorry, okay, I did a mistake. 2 into 13 into 5 into cos theta is equal to, 0. That means cos theta is equal to 0. That means theta is equal to 90 degree is your answer. So pi by 2 or 90 degree is your answer. Very good. Now let me give you one difficult question, star mark. I will not solve it. You have to solve it. By the way, if you want classes from me with affordable price, then definitely you can contact. I will give my WhatsApp detail in description or mail ID. You either WhatsApp me or mail me for classes in affordable price, physics classes. Thank you. Let me stop it. Bye bye.